Part 22f1fa19c3i. Line 22f1fa19c3i Calcite crystals, load transfer UFO engine 5G Wow Seti. There's the alien radio signal and the calcite crystals from load transfer data. So, quotes from Wiki: calcite is a carbonate material and the most stable polymorph of calcium carbonate, CaCO3. The other polymorphs are the minerals aragonite, and vaterite. Aragonite will change to calcite at 380 to 470 degrees Celsius, and vaterite is even less stable. So there's the doubly terminated calcite crystal. Quotes from Wiki: calcite crystals are trigonal rhombohedral, though actual calcite rhombohedra are rare as natural crystals. However, they show a remarkable variety of habits, including acute to obtuse rhomboedra, tabular forms, prisms, or various scalenhodra. Calcite exhibits several twinning types, adding to the variety of observed forms. It may occur as fibrous, granular, lamellar, or compact. Cleavage is usually in three directions, parallel to the rhomboedron form. Its fracture is conchoidal but difficult to obtain. It has a defining Mohs hardness of 3, a specific gravity of 2.71, and its luster is vitreous in crystallized varieties. Color is white or none, though shades of gray, red, orange, yellow, green, blue, violet, brown, or even black can occur when the mineral is charged with impurities. Calcite is transparent to opaque and may occasionally show phosphorescence or fluorescence. So the transparent variety, called Iceland spar, is used for optical purposes. Acute scalenhodral crystals are sometimes referred to as a dog-tooth spar, while the rhombohedral form is sometimes referred to as a nail-haired spar. At a wavelength of 590 nm, calcite has ordinary and extraordinary refractive indices of 1.658 and 1.486 respectively. Between 190 and 1700 nm, the ordinary refractive index varies roughly between 1.6 and 1.4, while the extraordinary refractive index varies between 1.9 and 1.5. Calcite, like most carbonates, will dissolve with most forms of acid. Calcite can be either dissolved by groundwater or precipitated by groundwater, depending on several factors including the water temperature, pH, and dissolved ion concentrations. Although calcite is fairly insoluble in cold water, acidity can cause dissolution of calcite and release of carbon dioxide gas. Ambient carbon dioxide, due to its acidity, has a slight solubilizing effect on calcite. Calcite exhibits an unusual characteristic called retrograde solubility, in which it becomes less soluble in water as the temperature increases. When conditions are right for precipitation, calcite forms mineral coatings that cement the existing rock grains together, or it can fill fractures. When conditions are right for dissolution, the removal of calcite can dramatically increase the porosity and permeability of the rock, and if it continues for a long period of time, it may result in the formation of caves. On a landscape scale, continued dissolution of calcium carbonate-rich rocks can lead to the expansion and eventual collapse of a cave system, resulting in various forms of karst topography. Okay, so that's the end of that video. We'll go into the next one.